Give me the grand total final answer that you got.
F of x equals x squared minus 7x minus 18.
Nice. Okay. Now, what if I told you to go backwards? Well, and you'd start with this, and you'd end up with that.
Yeah.
All right, so let's actually talk that through. Like, let's say this was the only thing you saw. Well, you'd start with two sets of parentheses, right? Josh, you with me? And then you'd make an x and an x. Yes?
I have a little trick.
Okay.
Makes this much easier for me.
Yep.
The y-intercept, to get the y-intercept, it's what two numbers multiply to that, but add together to make the middle number.
All right. So I agree with you, except that only works when there's a 1 in front like this. When there's another number in front, that won't work. But you're right. It's a really good trick when there's a 1 in front. Okay, so one thing at a time. I like to do the plus and the minus signs next. You could know those ahead of time? Yeah, I can tell. Can't be two pluses. Why can't it be two pluses?
Because there's negatives.
Yeah, it can't be two pluses. So at a minimum, there has to be one minus. But how come I knew that it wasn't both negatives?
Because a minus and a minus would make a positive in the final number.
Yeah, and this number's negative, so it has to be one positive, one negative. Okay, then the last thing is this. There's only two choices, 9 times 2 or 18 times 1. And which one do you think is going to make a 7? A 9 and a 2 make a 7, as long as you do it right. Okay, so then that's the key thing, where as long as you do it right. But honestly, if you just slap them in there, and you go, okay, I got 9 and I got a 2. You got to check it anyways. And you're at a 50-50 chance, but you check it and you see, did I do it right? Did I do it right? Well, 7x, negative 2x, that makes, oh, wait a minute, 9x and negative 2x, and that makes 7x. But wait, I wanted negative 7x. Whenever that happens, don't change the numbers.
Flip the signs.
Flip the signs. Number one, they're easier to change. I mean, heck, I could just go like this. Plus, minus. And number two, when it's more complicated, which is what's coming next, it's going to get more complicated tomorrow, or I guess in this case, Monday, when this lead number isn't 1, you don't want to change the numbers. So whenever you get the opposite of what you wanted, use the opposite signs. All right, moving on. This is all going to be about a equals 1, so that's in the lead term. Do you get it's harder to factor when it's like this? Because this number has got a 2 in front, that makes it a lot harder. We're not doing that until later. So today, a is going to equal 1, so that will only be a 1 today. Okay? All right. And then there's solving quadratics. What the heck is the difference? Let me show you. This is really important to just get this difference. What if you did this, then you factored it? Yay for you, you factored it. But I need one of those headphones. Can you stop the headphones for just a minute? We're going to be done in like 1 minute. Okay, but this is just factoring. It's not solving. Solving is where you go x plus 3 equals 0 and x minus 6 equals 0. Because there's two ways to make this 0. Either make this part 0 or make this part 0. And the solving thing is where you actually have numbers, not factors, numbers. 6, negative 3. Do you get the difference? Factoring is not solving. Factoring is awesome. It's my favorite thing. Honestly, of all the things we do, factoring is the number one thing that helps the most, and it's my favorite thing at this level of math. All right. Where do these even come from? X minus 1, x minus 3. You see how that's where they come from. Another way to say it would be if I had this equation, x plus 4 and x plus 2, it would really mean this graph. You know, because, wait a minute, those are the opposites of what you put. It's because the stuff on the inside is the opposite of what you think. It's flipped around. It's the backwards of what you thought. It's counterintuitive. All right. But wait, this one's a little different. What's different about this one?
It's flipped.
It's flipped. So you'd have to be careful. And wait, it's got another thing. You can't have a 0. Yes, you can have a 0. You just go x plus 0, which was the same thing as x, actually, right? And then this one, x, since this is a -4, what do? Plus 4. And then those are my two factors, but some kids are going to get smart and go, well, I could just call that other one x. So it's x times x plus 4. And yes, nice. The catch at the end is, oh, but it's upside down. Negative in the front. So there's my final answer. There's a lot of little gotchas in math. Okay. Okay, so now what? Well, pausing. Okay, so let's wrap this up. So, in last unit we did these things, but in this unit we're going to get factored from standard. So we got x squared plus 6x minus 7, and you got to be able to factor that. Yes?
Can I ask a mom about going home?
Pausing for a second. Okay, so basically we're factoring, and if you have this, that's standard form, and so we are factoring. So let's make two sets of parentheses here. And then, how do you always start? Come on, keep it simple.
You put the X's.
X's. Okay. Then, what's in the middle? What's in the middle? Signs. Signs. Everywhere. Signs. Plus and a minus. Why plus and a minus? There's a negative right there. What if there had been a plus right there? Well, if there was all positives, we'd have all positives. What if they were all negatives? Still plus and a minus. The only time you'll ever have a minus and a minus is the next kind of problem we're going to do. Okay, so this last thing is, what makes a 7? What goes here and here, Hazel?
A 7 and a 1.
And I can pick either spot. I don't care. 7 and 1. But because I'm going to check it with the outside and the inside. I call that the smiley face of factoring. See the smile? The outside and the inside. So I got 7x and negative 1x. And that makes a total of 6x. And that's what I wanted. What if it had been the opposite of what I wanted? Switch the signs. All right. Now here's the last kind. X squared plus 4x. Oh, wait, sorry. I told you I'd do this kind. Minus 4x plus 4. This is the trickiest kind. But with two parentheses, how do you always start? X and X. Put your phone in your backpack. Thank you. Don't take it out until we're done, which is very soon. All right, and now, plus and a minus, plus and a plus. What is it?
Minus and minus.
How do you know?
Because the first number is negative, and then the second one is positive, which would...
When this and this multiply together, you need it to be a positive. So yay, you get your ideal world. You still have a negative when it comes out here, but when you multiply these two numbers, 4 and 1, it is not 4 and 1. What is it? 2 and 2. This is the rare double root, because when you can, if you want to, put them like that. And then if I put a y equals, and then I put a plus 0, you might be like, vertex form, I recognize you. 2, 0. Oh, we haven't seen each other in so long. It's like since the test you had yesterday. Okay. All right. So this is called expanded. That's just standard form. Or it's just factored. But the thing that you'll not like about this is we just did a bunch where you had like 3 terms. It's called a trinomial. But what if there's only 2? It kind of messes up our system. But then we just have 1 parenthesis. And something goes in front of it. What is in both of these? X. And then what's left to go in here? X plus 12. Yes. That's still factoring.
It's just
All right, so let's do one more like that. 4x minus 36. What do they both have in them? An x? No.
4.
A 4. So then what's left?
X minus 9.
X minus 9.
That's the
Now, if you're not understanding how I'm getting those things in here, it's because you just divide this by 4 and you divide that by 4. And you get x and you get 9. Okay, so let's not do that slide. I don't like it. I don't like that either. It's just going to waste your time. I'm trying to get through it quick. How about this one? I bet you can factor that. What's the first thing, Beckett? Has to go in everything. X. What signs should I use next? Pink shoes. Plus and plus. And then the 12. Would you agree that a 4 times 3 makes a 12? But yet I'm not going to pick it. Why?
doesn't make
Because it doesn't make 8.
Yeah, a 4 and a 3 can't make an 8. So how about 6 and 2, though? There we go. Is this the solution? Kind of a trick question. No, it's factors. The solution would be what makes it equal 0. X equals -2 and x equals -6. Those are called solutions. These are factors. Okay, factor that one. And that's the last one we're doing, boys and girls. Nice, easy day. Josh, how did you start?
One's like x plus, and then the other one's x minus.
Good. And now we got to think 20. 20 times 1 makes 20. No. 5 times 4 makes 20. No. What's left?
10 minus 2.
10 and 2. And if you had just slapped them in, you have to check it, and you go 10x, -2x. That makes 8x. Oh, yay, I've got it. All right, and that's it for today. Now, what do you do for homework? Your homework is a worksheet that is at the bottom, and it's called optional. So here's what I'm going to do. I so rarely offer extra credit. Those of you who decide to do this worksheet, whether you are here or at home, either way, if you do the optional factoring worksheet at the bottom, which I think you're going to find pretty easy, the optional factoring worksheet, it's got 369 questions on it. I will give you extra credit. That is the first time you have heard me say that all semester. It's the first chance to get extra credit. Okay, so do the optional factoring worksheet. I'll throw a spot in the grade book for it, and you can get some extra credit. And that's all I got for you for today.